Hi everyone. Today we're going to be working on goal number 11, which deals with adding and subtracting rational polynomial expressions. Just to get started on this, we're going to do a quick review, make sure we remember exactly how to work with fractions. Okay. In example letter A here for the review, when we have fractions and the denominators are not the same, we know that we need to get the denominators to somehow be the same in order to put them together. So what we do is we look at the denominators and determine what's the least common denominator. In this case, 3 and 5's least common denominator is 15. So what we're going to do is we're going to take and get these to both be 15 by either multiplying or dividing in some cases, but more often than not, multiplying. So what we're going to do is we're going to take this first one, the 3, and we're going to multiply it by a 5. This will make it equal to 15 in the denominator, but remember, whatever we do to the denominator, we have to do to the numerator. So multiply this by 5, we're going to multiply this by 3 to make it 15, and multiply this by 3 to make it 6, which means that we will have 5 plus 6 over 15, which equals 11 over 15. Okay? Pretty sweet, simple, easy stuff that you guys should be able to all handle. When we look at letter B, we notice in this example that the denominators are already the same. And because they're the same, there's no work to be done to try to get them to be the same. So now we just add them together and we get 5x plus 3 over x plus 2. But let's not forget, because we're talking about rational expressions, we have to talk about possible domain restrictions, which means in this case that x cannot equal negative 2 when we solve it. And this will be our complete answer here. So let's start off with some easy problems then in relation to what we're going to see in this unit. Okay, looking at these, right here what we've got is two different values for the denominator of 2 and 8, and then the x's are the same, the y's are completely different. What we're going to do is we're going to get them to be identical so that we can actually go ahead and add them together. So in order to do this, let's look at the numbers first. Looking at the numbers, the least common denominator between 2 and 8 just happens to be 8. So what we're going to do is we're going to take this 2 and multiply it by 4, and we're going to multiply this top part by 4 also. So now we have 8 and 8, we have x and x. When we look at the y's, we have a y squared, but we don't have a y squared on this one. So let's go ahead and put a y squared into the problem as well. Put a y squared here, put a y squared up here as well. And now that our denominators are identical, now we could just go ahead and do the operations of combining them. So if we combine them, in this first term we have 12y cubed plus we have 5z. And then for the denominator, we have 8xy squared for both. So it's 8xy squared. And again, since we have fractions, let's talk about the domain restrictions here. X cannot equal 0. And in this case, y cannot equal 0 as well. So that takes care of our very first problem. Looking at the second example here, our denominators are definitely different, so let's work on trying to get them to be identical again. So let's start first with the values. When we look at 5 and 10, the least common denominator between 5 and 10 happens to be 10. So let's multiply this by 2, multiply the top by 2 as well. So going part by part, we have 10 and 10. We have a cubed, but we only have one a on this one. So that means we need to put 2 more a's on the right side. So let's multiply this by a squared, and let's multiply the top also by a squared. Let's look at our b's. We have a b squared and then a b, which means there's 2 on the left and only 1 on the right. So let's go ahead and put 1 more on the right side. So now our denominators are the same. We have 10 a cubed b squared for the denominator. So let's put these together. We have 8 plus 9a squared bc. Try to put it alphabetical if we can. 9a squared bc. And for the denominator, we have 10a cubed b squared. Again, let's talk about the domain restrictions on this one. A cannot equal 0, and B cannot equal 0. So this is our total problem right here. All right, those were the easy ones. Now let's switch gears over to the more complicated ones. Look at a problem like letter C. In this problem, our denominators are not the same. So the question is, can we get them to somehow be the same? We can't just add or subtract things to it. So start off first always by factoring these if we can. So when we look at the first one here and we factor 6x minus 18, we know that we could take out a 6 from it because of we look for GCF first, which means we're going to have 6 and then the quantity x minus 3. There's nothing else that we could do to that, so let's go ahead and rewrite it down here as 6 times the quantity x minus 3, and then we have a 5. Looking at that right side there, we have 4x squared minus 14x plus 6. Let's start by first looking for a GCF, which it just happens to be. So we take out a GCF of 2, and we're left with 2x squared minus 7x plus 3. We see if we can factor any further. We know this is a trinomial, leading coefficient not equal to 1. So let's go ahead and do our bottoms-up method. Put a negative 7 here. Positive 6 from doing A times C. Factors of 6 that add up to negative 7 are negative 1 and negative 6. Divide by my A value, which happens to be 2. And this will become a negative 3, and this will not reduce. That means the factored form for this would be 2 brought down from here. And then from here we're going to have 2x minus 1. And then from here we're going to have x minus 3. Oops, sorry, I didn't realize I was off the screen there. Alright, so that's our factored form for that. So let's go ahead and put that back up here. We have the quantity x minus 1 on the top. And on the bottom we still have 2 times 2x minus 1 times x minus 3. So this is the factored form of our original problem here. Now, let's work on getting the denominators to be exactly the same. When we look at the monomial in the front, we have a 6, but we also have a 2 over here. The least common denominator of 6 and 2 is 6. So let's multiply this side by 3, and we're going to multiply the top also by 3. When we look at the next binomial, we have x minus 3 here, and we already have an x minus 3 here. So those are the same. We don't have to worry about anything else with that. But when we look at the 2x minus 1, we're missing the same thing from the left side. So let's go ahead and multiply that left side by a 2x minus 1. And if we do it to the bottom, we also do it to the top. Okay? So now we've got 6, x minus 3, 2x minus 1, our denominators are now identical. Now that they're identical, let's go ahead and rewrite this with the denominators written out. Together, x minus 3 and 2x minus 1. And the numerator, let's go ahead and multiply this out. Now, notice we have a minus sign here. That means that we're going to be distributing a negative 3 to the right side there. So write it out. We got 5 times the quantity 2x minus 1 minus 3 times the quantity x minus 1. From there, let's continue to simplify. We have 10x minus 5 minus 3x plus 3 over 6 times the quantity x minus 3, 2x minus 1. Combine like terms here. We end up with 7x minus 2 over 6 times x minus 3 times 2x minus 1. Now, we've got a fraction, so let's talk about our domain restrictions on this. For this one, we get that x cannot equal 3. This one is the doozy that a lot of people mess up. Remember, it's saying that 2x minus 1 cannot equal 0. So if we work through and solve, we say that 2x cannot equal 1, which means x cannot equal 1 over 2. So this is your final answer. You have 7x minus 2 over 6 times the quantity x minus 3 times quantity x minus 1, along with these domain restrictions right here. It's not too many steps. Hopefully you were able to follow along with it. It seems like a lot of work because you have to do a lot of rewriting, but it's really not too bad. Let's take a look at letter D. Okay. Try to copy this one down and then go ahead and do it, or check your answer with me on this one. Okay. So again, let's go ahead and take the factored form for each one of these. So first off, we have 4x squared plus 21x plus 5. No GCF, so let's talk about doing bottoms up since the leading coefficient is not equal to 1. Got 21 and a 20. Factors of 20 that up to 21, or 20 and 1. Using our a value of 4, we're going to divide by 4. This equals 5. So that means that my first factor for this is x plus 5. And my other factor over here is 4x plus 1. So let's go ahead and rewrite that first term there. We get x minus 8. And then we have x plus 5 times 4x plus 1. For the right side here, 12 times x, or 12x plus 3. The GCF for this that we could take out is going to be 3 times 4x plus 1. Nothing else we could do with that, so let's go ahead and rewrite this. We have 6 over 3 times 4x plus 1. And now we've factored the denominators. So because we factored the denominators, we can keep moving forward with now getting the denominators to be the same. So looking at the coefficient, or leading coefficients here, or the constant, I guess, or the monomial, we have a 3 on the one on the right, but we don't have a 3 over here. So let's multiply this one on the left by 3, and let's also multiply this top part by 3. We look at the one on the right, and there's a 4x plus 1, and there's also one on the left side, but there is not an x plus 5 on both sides. So let's go ahead and multiply the one on the right by x plus 5. And then let's check, do we have the denominators the same? We have a 3, we have an x plus 5, and we have a 4x plus 1 in each of them. Now that the denominators are the same, let's go ahead and rewrite this with all of it being put together as one problem. So 3 times x minus 8, there's a plus here, so it's going to be positive 6 times x plus 5. All over 3 times x plus 5, 4x plus 1. Let's go ahead and keep simplifying. We have 3x minus 24 plus 6x plus 30 over 3 times x plus 5 times 4x plus 1. Combine like terms here. We have 9x plus 6 over 3 times x plus 5. And then just for the heck of it, if you can factor the numerator, let's always try to factor the numerator. We could take out a 3 from that first, from the numerator. We have 3 times 3x plus 2 over 3 times x plus 5 times 4x plus 1. The reason we always try to factor the numerator if we can, and I didn't do it on this previous example because there was no common value that we could take out from them, is look at what happens here. In this example, my 3's in the fronts can cancel out. So let's go ahead and cancel these out. And what we're going to be left with is a really nice answer at the end of 3x plus 2 over x plus 5 times 4x plus 1. Again, the domain restrictions here, we say that x cannot equal negative 5 and x cannot equal negative 1 over 4. And this is it. I hope this helps. These aren't too challenging. The only really tough part about it is making sure we just go step by step through it. Watch them again, try them again, seek me for help, but hopefully this did it for you and you're good to go. Have a good one.